So I'm going to talk about the OW2's software for performance testing and monitoring with the CLIF platform. So what is performance testing and monitoring? Just to be sure that we share the same level of knowledge. So with performance testing, what you want to do is that you have an application or a service that is not online yet, and you want to check its performance before putting real users on it. So you are going to emulate the workload of these real users with load injectors. Here there are 3 machines that do load injections with the CLIF software. And then you will check the behavior of your application. Is it behaving correctly? And are the response times correct, typically? Then with performance monitoring, the goal is a little bit different. Even though you still use a load injector to generate traffic, here you will generate a small traffic because you already have real users because your system is online. And what you want to check is the quality of experience of your system, service, application. So this light traffic will perform the same traffic as a single real user, for example. And then you check that your platform, your service is behaving correctly. Briefly, CLIF, a very brief presentation of CLIF. CLIF is a generic, adaptable Java framework for distributed performance testing and monitoring. So it comes with traffic generators that support out of the box a number of protocols. You have the list here. And if you don't find the protocol you need, then you can very easily write or wrap your protocol and integrate it to CLIF. In the same way, you can also add some plugins to have specific datasets in order to parameterize your scenarios. CLIF also comes with probes that will measure the consumption of your resources. Out of the box, here again, there are a number of probes for typical system resources. But here again, you can wrap your own probes and integrate it into CLIF. It's really done for that. One of the peculiarities of CLIF is high power. We at Orange had some test cases where we used up to 1,000 load injection machines in parallel. And we also have test cases where we need to have hundreds of thousands or even millions of virtual users in a single load injector. And all this is working. But of course, you can also run just a single virtual user in a single load injector typically if you are doing some performance monitoring. Just like Nginx, CLIF is a mature project, I would say. It was launched 15 years ago, and I would say that it followed the trends of computing science during these years. We started from a component-based architecture with using the fractal component model from Object-Web, now OW2. We started also from Java technologies using, CLIF is entirely developed in Java, and the main graphical user interface of CLIF is based on Eclipse. Then we did some work in the field of autonomic computing, and we developed some control loops to make some self-driven test campaigns. And this was contributed as the self-bench module. And in the recent years, we are really working on automation and automatic provisioning of testing infrastructures. So we did some work with OpenStack or with the proactive middleware to get those testing resources and infrastructures on demand. And we also automate deployment of tests using a Jenkins plugin and a Docker image now. So this the CLIF project is a rather old project now, and there have been a number of developments. And so let me show you, explain you what are the main distributions and modules that you need to run CLIF. The first one is the simplest one, is the CLIF server distribution, which is the basic CLIF runtime that you need if you need to install on a machine if you want to deploy a load injector or a probe. And it comes with just a command line interface, but a full-fledged command line interface. Then you have the swing GUI, which is basically the same distribution, but with a simple graphical user interface, which is dedicated to running tests and performing some performance analysis and reports. Then the main graphical user interface, the full-fledged graphical user interface, is what we call the CLIF console, which is based on Eclipse. So here you can do you get all the features of CLIF, including writing complex scenarios. And moreover, since it is based on Eclipse, you have an integrated development environment that provides support for extending CLIF. And especially there is an Eclipse wizard for writing your own plugins for load injection, for example, to integrate a new protocol or integrate a new dataset provider. And finally, there is a CLIF plugin for Jenkins, which helps automating test runs, performance reporting, and quality of experience alerting, either in a monitoring approach or in a continuous integration approach. Then installing one of these packages is very, very easy. You just have to download it from clif.ow2.org, unzip, and there is just one dependency, which is Java 8 runtime, Java 8 or later. For the CLIF performance testing plugin for Jenkins, it's even easier. You get it in your Jenkins plugins manager. It's because it has been contributed to the Jenkins community early this year. From Docker, it's simple, just a command to get the image. And once you have installed the CLIF software, you can easily get support from the CLIF website, where you will find a user guide, examples, tutorials, videos, presentations, Javadoc for developers. And if you have any question, don't hesitate, or any remark, don't hesitate to use the CLIF mailing list. Here is an overview of the command line interface, just to show you that it's really a complete set of commands that will allow you to deploy tests or execute them, get some statistic reports, and doing a lot of execution control or configuration control during test executions. And all these commands are just the same if you are running this on Windows, on Mac OS X, or on Linux, or any Unix-like environment with Java. Here is just a screenshot of the main graphical user interface based on Eclipse. On the left part, you see the list of test projects with, and each project is a folder containing all the resources, so the test plan, the scenarios, the datasets, and so on. Then on the upper part, you see the list of load injectors or probes. Here there is just one single load injector in this example. And in the bottom part, you see the monitoring part, which is convenient because when you run a test, you want to see in real time if it's performing correctly. Otherwise, it's not the case. You can stop the test immediately and and fix it. This is the performance reporting tool, which is we did a lot of work on this tool to get something that is very efficient, very easy to use, and very powerful to get any kind of performance analysis on response times, of course, and also on the measurements of resources usage. For example, here you have a scatter plot of response times. So each request, for each request, there is a dot on the plot. We see the CPU usage. We also see the throughput in requests per second. Well, there is, so you can mix every kind of measurement from any test. And when it's ready, you can generate a number of pages with one plot. There will be automatically you will have a statistic analysis with all the main statistical values, and then you can export it to HTML. Now let's have a look at the reports generated by the CLIF plugin for Jenkins. This is the detailed performance report where you find for each request type, for example here UDP connect, UDP receive, or UDP send. You will have a global statistical array with all values. And for each action type, you get 5 graphs that we'll see in the next slide. And you also have in the first, the upper part here, you have, we see that we had a JVM probe. And so you can analyze also the consumption of the memory of the JVM, if you like. Here are all the graphs that are generated. The first one is the scatter plot. Then on the right, you have the moving statistics about response time and throughput. Then you have the histogram of response time, and finally the quantiles of response times. And all of this is generated automatically for each test. And then something is very useful too is the performance trend from through a successive test. So we see here the evolution of the performance with the maximum response time, minimum, average, and also the standard deviation. And also we see if there are some errors or not, because it's important to check that answers are correct. And this is typically useful in continuous integration to see if there are some performance regression, and also, of course, in monitoring usage. So this is the last slide. What's coming next with CLIF? Well, as you probably have understood, we really work a lot about automation today, and we are doing something with Activion right now in order to integrate metal as a service, so bare metal resources in our tests. We are working also now with Ansible, and we probably will publish some rows on playbooks, and we'll do also some more automation in OpenStack environments. And for developers, there will be some evolutions because we are going to move from a Subversion to the GitLab, to OW2's GitLab instance, which will imply a big code base reorganization, because today the Subversion code base is very monolithic, and we have to split that in a number of repositories. And as far as continuous integration is concerned, well, Bamboo is out of order right now, so we'll have to move to GitLab CI. Okay, and we are still working on, well, completing the move from the legacy CLIF to the proactive CLIF. And so what's coming next is your question now or later. Thank you.